notice watching movies where someone comes running out of a burning building, oh my gosh, I'm on fire? Is there really fire around them? Okay, you all have way too much faith in computer animation. Was there usually fire on them?
Yeah.
Most of the time there's some kind of fire around them. It's kind of tough to draw that in, it's pretty expensive. So you put fire around them, but you want to make sure they don't get hurt. So what could possibly absorb the heat from fire? We need something that's as good as an early childhood educator at absorbing energy and redirecting it. Something that's really, really good at keeping things cool. How about more water? So, how about a bowl of water? Make it a little easier. Great. If I cover myself in water, would I be okay? Okay. Prepare to be amazed. It's not going to work. Why not? What's the problem? My hand leaks. Yeah. What happened? I was built that way. Great. So I need some way to keep my hand from leaking. So can you imagine some way I can get the water to not fall out of my hand? I could freeze it. Great. So then you've got a shivering actor going, I'm on fire, and running out of the building in ice, and it would chip off and fall. Would that be awkward? Very, very awkward. Take my shoe before I run out of hands. Okay? But I like the idea of somehow making that water not move. So we could freeze it. That might be a little too solid. We could just stick it in the container. Ooh, now are you impressed? Now, could I put fuel on top of here? So, impressive movie, right? Oh, I'm on fire. Look out. We need a way that'll stay flexible, but still be, and not fall off. So the problem with even something like a cup, you have to keep it very, very carefully, or it might spill. Right? You've seen that before. It might spill. Spilling would be bad. Maybe we can fix that problem. Al? Can I spill a little water? Here you go. Set up the dissonance. What's mostly in this cup? Oh, it's not liquid nitrogen. You're so totally doing your research. You have no idea how much liquid nitrogen ice cream we make on a daily basis. What I added here was a very small amount of powder. Teeny tiny amount. Just barely. Did anyone even notice it? Has anyone ever seen the old magician's trick where you pour water into a newspaper and, exciting, right? You put this stuff. You've probably used this before. A little tiny polymer, a little tiny set of bunch of molecules, little powder that can form long chains when it gets into water. And just like sauce sticks in spaghetti, you want to stick lots of water in between those long chains. Think about the last time you wanted a human not to leak. Early childhood educators. When do you want a human not to leak? That's the stuff they put in diapers. No, it's not recycled, but thank you for thinking it. This is the same stuff, sodium polyacrylate. What's this cup mostly filled with, though? Water. It's water with a little tiny bit of something that just sticks to the water. So now I've got a way to get the water to stay on my hand. It's a pretty good deal, because now I can coat myself in it. Need some extra before, just in case. Always have two ovens. You know that, right? Yep. So now I can coat myself in water, and the neat thing is the water's not going anywhere. I can flex around. If I did a really good job before a movie, you spend hours, and makeup people do it, they paint it, it's beautiful. But whatever, I've got water on my hand. If I put fire on that, is it going to burn? No. It's still mostly just water. Good deal. So now, there's some fuel on it. Should I put fuel on my hand? And light it? Yeah. What, you thought I was going to bring stuff for out of early childhood? We do professional development. This isn't it. So, we play together. You'll have stuff you can do with your kids. Don't do this with your kids. But the neat thing is, as long as you've got something that can redirect that energy, absorb that energy, hold on to that energy without changing, like you guys need to be prepared to do in your classrooms, pretty much good. Photos. Guy with the big camera. I'm on fire. Hi. Where we usually usually end up using this one is when we want to talk about what happens when things warm up and where does stuff go when it disappears. With younger kids, it ends up being persistence of matter. What's a good way to put this out? Water! Water is so good at absorbing energy. If I pour some water on there, will we hear anything? What do we hear? Not. There's so many senses that happen when you do these things. You know? So you've now just experienced it without me having to bring any of it to you. You're not on fire, but you felt the water, you felt the sizzle, right? It all happened. You made it many sensory, very, very quickly, very easily. It's probably a little tough to hear. Can you hear that? Yeah. So where we usually like to use this is as a stepping off point for saying, well, where does the water go? Why does it sizzle? Where does the water go? Evaporates. So now it's in the air. You give it energy. Sometimes you give it too much energy, runs away. Y'all aren't going to do that, right? Good. So